Hey class, here is the Unit 11 test review. So I said I would make a video for you, so here it goes. So the first question was evaluating the 6 trig ratios for the indicated angle. So notice that this right triangle has already been solved, so you have all 3 sides. So then here's my angle. So across from the angle will be my opposite side. Remember, next to or adjoining is your adjacent side. Across from the 90 degree is your hypotenuse. And then we did use the, acronym maybe, Sohcahtoa, to help us remember the main trig functions. So then we could say that sine of theta is opposite over hypotenuse. So that's going to be the square root of 10 over 5. So opposite over hypotenuse. Then cosine of theta will be adjacent over hypotenuse, so 3 over 5. Then tangent of theta will be opposite over adjacent, so square root of 10 over 3. And then the other 3, so those are the 3 main ones. The other 3 are the reciprocal functions. So we have cosecant, which goes with sine, CSC of theta. You have secant, which is the reciprocal of cosine, and then you have cotangent, which is the reciprocal of tangent. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, or 5 over the square root of 10. Now for that, you will need to rationalize it, so multiply both the numerator and the denominator by the square root of 10. It'll be 5 times the square root of 10, and then on the bottom, it'll be the square root of 100, which just simplifies to 10. Now that can be simplified one more time because 5 over 10 simplifies to 1/2. So it'll be 1 square root of 10 over 2 is your final answer for cosecant. Secant is a reciprocal of cosine, so hypotenuse over adjacent, or 5/3. Then cotangent is a reciprocal of tangent, so adjacent over opposite. Now that one needs to be rationalized as well, so multiply both by the square root of 10. You get 3 square roots of 10 all over 10. And we got our 6 trig ratios of that angle theta. This example is the same idea, except for that I'm missing the hypotenuse. We'll call that C. So the Pythagorean Theorem says that if you have a right triangle, the sum of the square of the legs equals the hypotenuse squared. So basically a squared plus b squared equals c squared. So I can solve for c by saying that a is 2 plus b is 3. So 2 squared is 4, 3 squared is 9. That'd be 13. So c equals the square root of 13 because you'd square root both sides. And then it's the same example basically that we just did. This would be the side across is opposite, the side next to is adjacent, and this is hypotenuse. So sine of theta, using Sohcahtoa, sine of theta will be 3 over the square root of 13, opposite over hypotenuse. Rationalizing that, it's going to be 3 square roots of 13 all over 13. Cosecant of theta goes with sine, so that'll be the square root of 13 over 3. And that one's done. Cosine of theta be adjacent over hypotenuse. Rationalizing that by multiplying by the square root of 13 gives me 2 square roots of 13 over 13. Secant is the reciprocal of cosine, so square root of 13 over 2. Hypotenuse over adjacent. That one's done. Tangent is opposite over adjacent, so 3 over 2. And cotangent is the reciprocal adjacent over opposite, 2/3. Given a point that lies on the terminal side of an angle in standard position. So here we have 4, -1 is right here. So we're looking at this angle that's formed with the terminal side goes through that point. And then we have x, well, our x distance is 4, and our y distance is -1. And then here's our theta out here. But remember that the reference angle does have the same value, so you could put your reference angle here, and then find your trig functions from that. Or you can come off to the side and remember that if you have your point on your unit circle, this is x, y, and r, and your theta is always here. And then using Pythagorean's theorem, you know that x squared plus y squared equals r squared. So if x is 4, 4 squared, and y is -1, y squared equals r squared. That's 16 plus 1 equals r squared. So r squared equals 17, or r is the square root of 17. So we got r is the square root of 17. That's our radius from the center down to our point on the terminal side. And now we can find the 6 trig functions using the Sohcahtoa again. So sine of theta will be opposite over adjacent. Opposite is always the y side, adjacent is the x, and then the hypotenuse is the r. And remember that sine goes with the y values when we graph it. So sine is the y values. So sine of theta is y over r, or that will be -1 over the square root of 17. You will have to rationalize that, square root of 17 by both, and you get -1 or -1 square roots of 17 all over 17. Cosecant, or CSC of theta, is the reciprocal of sine, so r over y, or the square root of 17 over -1, which is the negative square root of 17. Cosine of theta, adjacent over hypotenuse, or x over, not y, I meant x over r. X is 4, r is the square root of 17. Rationalize that. Get 4 square roots of 17 over 17. Secant of theta is r over x. So that'll be the square root of 17 over 4. That can't be simplified anymore. Tangent of theta is opposite over adjacent. So that's y over x, which y was -1 and x was 4, so -1/4. And cotangent is x over y, which is -4 over 1, or -4. So that's that example. So you graph your point, and then find your radius, and then use these ratios from this triangle, or draw your reference angle with the x-axis and then use that. Evaluate the trig function and give an exact answer. So the tangent of 150, for these ones, you need to first draw the angle and then find the reference angle. So draw it and then find the reference angle, which is always with the x-axis. So this will be a reference angle of 30 degrees. And then you find the trig value of that reference angle using your special right triangles. So if this is my 30, 60, 90 triangle, since I have a reference angle of 30, across from the 30 is the smallest side, that's a 1. Across from the 60 is going to be the square root of 3, and across from the 90, that's my largest side, is 2. I want the tangent of 30 degrees, and that's the toa part of Sohcahtoa. So that's opposite over adjacent. So opposite is across, so this is opposite, and this is adjacent. So tangent of 30 will be 1 divided by the square root of 3. You do need to rationalize that. So your tangent of 30 degrees is the square root of 3 over 3. Now 30 degrees is in the, I shouldn't circle that yet, not quite done. Tangent of 30 degrees is in the first quadrant, so the tangent of 30 is positive. But the tangent of 150 degrees is in the second quadrant, and tangent's negative there, because all positive in the first quadrant, sine and cosecant are positive here, tangent's positive in the third quadrant, and calculus, cosine, and secant are positive in the fourth. So all students take calculus. Since it ends in the second quadrant and only sine is positive, your answer will be negative square roots of 3 over 3. All right, the next example is 3 pi over 4. Cosine of 3 pi over 4. Before we can do the first step of draw it, we need to know what it is in degrees. So the first thing I need to do is to change this into radians or degrees by multiplying by 180 over pi. So I want to cancel out the radians and make it all degrees. Now 180 can take out a factor of 4. It's the same thing as 4 times 45. So then I can factor out a 4. Then 3 times 45 is going to be 135. So I want the cosine of 135 degrees. So now I'm at my first step, draw it. Second step, find the reference angle with the terminal side and the x-axis. So that is 45 degrees because 135 plus 45 makes a straight line and 180. So you could take 180 minus 135 to get 45 degree reference angle. Since it's 45 degree reference angle, I need the 45, 45, 90 triangle this time, which is 1, 1, square roots of 2. You can use either 45 degree angle, doesn't matter, but you want the cosine of 45 degrees. The cosine of 45 degrees, cosine is adjacent over hypotenuse, so adjacent over hypotenuse gives me 1 over the square root of 2. I do need to rationalize that by multiplying both by the square root of 2. So it'll be the square root of 2 over 2. So the cosine of 45 is the square root of 2 over 2. Now the cosine of 135 is going to be negative square roots of 2 over 2. And it's negative because 135 is in the second quadrant again. So all students take calculus. 135 is in the second quadrant, only sine is positive there. So cosine then would be negative. All right. Find the exact values of these angles. Notice that 270 and pi, those are our quadrant angles. Our quadrant angles are 0, 90 degrees, or that's pi over 2, 180 degrees, or that's pi, 270 degrees, that's 3 pi over 2, or 360 degrees, and that's 2 pi. These quadrant angles have the special values on our unit circle. This is the point 1, 0. This is the point 0, 1. This is negative 1, 0. And this is the point 0, negative 1. And then those points correspond. Remember, cosine goes with the x coordinate, and sine goes with the y coordinate, so x and y. So if I asked you the cosine of pi, you could quickly tell me that the cosine of pi is negative 1. Or if I said, what's the sine of 90 degrees, you could look up at the first axes at 90 degrees and see that the sine at 90 is 1. It does make it a little different, a little bit tricky if I give you a reverse function, so like an inverse or a reciprocal function like the cosecant of 270. So what you would have to do for cosecant of 270, you can either do it two ways. You could say that the sine of 270 would be the y coordinate, which is negative 1. And so the reciprocal of -1 is still -1. The other way you do it is you choose this point 0, -1 on your 270. And that means that you have a radius, your unit circle, your radius is 1. You picked 1 point away from the origin. And then you have x, y, and r. And then you get those ratios from this triangle. X, y, r, here's your theta. So cosecant, it'd be r over y. Or cosecant of 270 would be r over y, which is r is 1, y is -1, so the cosecant is -1. So for cotangent of pi is right here, 180 degrees. So you'd pick the point -1, 0. And then you remember that cotangent is adjacent over opposite. So it would be x over y. So it's going to be -1 over 0. So the cotangent of pi is actually undefined there. Cotangent at 180 is undefined. In standard position means that you start at the initial side is always your positive x-axis. Your vertex is always at 0, 0. If it's positive, you go counterclockwise, then this is 90, so 150 would be like right about here. And this is your terminal side. So you need 3 things there. You need the vertex, the initial side, the coterminal side, and the direction that you are graphing it. So if I wanted to do -240, for example, I would say this is my initial side, my vertex, I'm going this way, and here's my terminal side. So those are how to sketch angles in standard position. So positive, you go counterclockwise. Negative, you go clockwise. Couldn't think of the opposite. Find the reference angle. So first, draw the angle. 140 is right about here. It's positive, so you're going counterclockwise. And the reference angle is always with the x-axis. So it's with the terminal side and the x-axis. So that makes this angle right here. And it's got to be acute too. So the reference angle is always less than 90 degrees. So this whole line here makes 180. So 140 plus 40 more degrees would be the reference angle. And we use theta with the apostrophe to mark that. 230 degrees. 230 degrees is right about here. Since this is 270, this is 180. Just remember that you always have to go back to the x-axis for a reference angle. So the reference angle is this angle right here, not the angle that connects back to here, not this one. So to find this one, I would actually do 230, take away 230 minus 180, and that would be 50 degrees. So the reference angle for this one is 50 degrees. 295. So this is 270, this would be 360, so 295 would be almost all the way around. So how much more to get back to the x-axis? My reference angle is always with my x-axis. So the reference angle would be right here. So this time I could do 360 minus 295. So 5, 6, 165. So the reference angle here would be, oh, that doesn't make sense. 65, sorry. It's got to be acute. I borrowed incorrectly and subtracted, but there we go. So notice that in all of them, I did something different. Here I did 180 minus 140 to finish out that one. Here I did 230 take away 180, and then here I took 360 take away 295. So you really just have to think about it. There's not a rule like subtract 180 every time. It's how do you get back to the x-axis, and it has to be an acute angle. Okay, changing to radian measures. I'm actually going to change this from 245 to 240, or let's do 230. I just want something that ends in a 0 so that it's a little bit easier to work with without a calculator. So if I want radian measures, I need to multiply by pi over 180. So this is pi is radians, 180 is degrees. So when I do this, I'm canceling out the degrees. And so then I can divide them both by 10 and get 23 pi over 18. And so I guess that's as far as I can go with that one. Let's say it was 120 degrees. So I'd multiply that by pi over 180. I can put 120 over 1. I can take out the zeros. I can go 12 pi over 18. And then both of those are divisible by 6. 12 is 6 and 2, and 18 is 6 and 3. Then I can take out a 6, and then my final answer would be 2 pi over 3. So I wanted to give you an example that you can do without a calculator. Okay, so 5 pi over 6 to degrees. So 5 pi over 6. To go back to degrees, now you want radians to cancel. So we're making a unit conversion. So I want radians to cancel and degrees to stay. So degrees goes on top. So then pi cancels. Now I want to take out a factor of 6. So I want to think of 180 is the same thing as 6 times 30. Because then I can take out a 6 from both. And I rewrote the 180. So now all that's left is 5 times 30 over 1. And 5 times 30 is 150. Since 5 times 3 is 15, add a 0, 150 degrees. So it's all about either pi over 180 or 180 over pi. Remember that you want, it's like you're making a unit conversion. So if you're going to radians to degrees, you want radians to cancel or vice versa. Coterminal angles, one positive and one negative. So coterminal are angles that start and stop in the same place. They have the same terminal side. So if I have 175 degrees, that is like right about here. So I want an angle that starts and stops in the same place. So if I start here and go all the way around, that's 360 plus another 175. Now I have an angle that started and stopped in the same place. So 175 plus 360 would give me 5. Wait, sorry, I'm doing my math wrong here. 7 plus 6 is 13, 535. So 535 degrees is one positive coterminal angle. Now I need to go negative. So what if you start at the positive x-axis and go in the negative direction? What's that angle? Well, to get that one, essentially you're going to have to, you could probably see this one's kind of easy to see. It's negative 185 because I go almost all the way, or I go the full 180 and then another 5 degrees. But to figure that out, you have to subtract 175 minus 360. To do that without the calculator, you really have to take 360 minus 175 and then make your answer negative because you have to start with the bigger number to do traditional subtraction here. So then I'd have to borrow. I have to borrow again. Then 10 minus 5 is 5. 15 minus 7 is 8. And 2 minus 1 is 1. So 185. And since it was actually supposed to be 175 minus 360, it's negative. So that's how you get those two terminal angles. To do it in radians, you could either add and subtract 2 pi, essentially. So 11 pi divided by 4 plus 2 pi would be around my circle one more time. Now 2 pi, that's really 8 pi over 4 because I need a common denominator. So 8 pi divided by 4 is 2 pi. So that's 16 pi over, oh wait, not 16 pi. 8 plus 11 would be 19 pi over 4. That would be one answer. And then if I did 11 pi over 4 minus 8 pi over 4 would be 8, 9, 10, 11. So 3 pi over 4. This is another positive answer. So I'd have to take 3 pi over 4 and subtract another 8 pi over 4 again to get a negative 1. So that'd be negative 5 pi over 4. So that's how you do it with radians, because 2 pi is the same thing as 360 degrees. You can, if that all else fails, change 11 pi over 4 into degrees. So we have 180 over pi. So that's 4 and 45. So I could take out the 4 and the pi, and then it would be 495 for 45 times 11. So 495, and then minus 360, 531, 135, same thing as 3 pi over 4, minus 360 again. I'd actually have to do it the other way around though. 225, negative 225 would be negative 5 pi over 4. So then you have to convert it back. Okay. At what angle should the slide be at? We actually didn't learn that this year, so we can skip this one. Okay, so this one tells me that B is 30 degrees and C is 90. So that means that A is 60 because these have to add up to 180. So it's a 30, 60, 90 triangle. And 30, 60, 90 triangle, when I'm solving it, is the ratio x, 2x, and x square roots of 3. Or the long leg is the square root of 3 times the short leg, and the hypotenuse is 2 times the short leg. So if you know the short leg, you can get the long leg and the hypotenuse pretty easily. I know the across from the 60 is 4, so I know the long leg. So I know that this one right here equals 4. So if I set that up, the long leg equals x square roots of 3, or the short leg, times the square root of 3. Then I can divide the square root of 3 on both sides to get the short leg. And then you have to rationalize that. So 4 divided by the square root of 3 will be 4 square roots of 3 over 3. That's a funky looking 4. 4 square roots of 3 over 3. So that would be my short leg. So 4 square roots of 3 over 3. And then the hypotenuse is 2 times that short leg. So then I just take 2 times 4 square roots of 3 over 3. And just remember that 2 is a whole number. So when you're multiplying it by a fraction, you put it over 1. So then you multiply just the 2 on top. So 2 times 4 is going to be 8 square roots of 3. And 1 times 3 is 3. So C is going to be 8 square roots of 3 all over 3. So those would be my 2 sides. Graphing. I think this will be the last one that I'll do because it looks like it'll kind of cover everything. So amplitude is 2, period. You take 2 pi divided by b, where b is in front of your x. So b is going to be a half here. So 2 pi divided by 1/2 is going to be 2 pi times 2 over 1, because dividing by a fraction. So that's going to be 4 pi. If I know that it ends at 4 pi, take 4 pi times 1/4. That's going to give me just 1 pi. So that's what I'm counting by. So 1 pi, 2 pi, 3 pi, 4 pi. Period is 4 pi. The shift is at the end here. It's been shifted down 3. So 1, 2, negative 3 is right here. And that'll be negative 4, it'll be negative 5, negative 1, negative 2. So I make my table. I always start with x is 0. And then I have pi, 2 pi, 3 pi, 4 pi. Then I'm graphing sine here. So if I look back at my unit circle, 1, 0, 0, 1, negative 1, 0, 0, negative 1. Sine is the y coordinates. Sine goes with y. And sine goes with y because sine is opposite over hypotenuse. Opposite is y. So sine starts at 0, and then we go 1, then to 0, then to negative 1, and then back to 0. And this time I do need an AY column for my parent function table because my amplitude is 2. So multiplying everything in this column by 2, I get 0, 2, 0, negative 2, 0. And then you can graph that. Now you could graph it up here and move each point down. So 0, 2, or wait, 0, 0, 0, pi 2, 0, 0, negative 2, 0, 0, and then move each point down. Or you graph from your shift. So you're graphing from this line right here, and you pretend that's your 0, 0. So 0, 0, I'm going to have to pick a different color to graph in here. Let's do pink. And then pi 2 would be right here, and then 2 pi 0 is right here. Then 3 pi negative 2 goes down to negative 5, then 4 pi 0. So if I took those orange dots that I had originally graphed and moved each one of those down 2, I would be at the right spot. Or, oh, down 3. I'm sorry, my shift was down 3. So moving them each down 3. I was like, why isn't that working? Down 3, then I'd get my pink dots. So that's another way of doing it. It's just more work. All right. Hopefully that was enough. If graphing or finding the intervals is still bugging you, I would suggest going back. I have 3 videos on graphing, sine, cosine, and translations. So watching those would be highly recommended. Okay, hope this was helpful. Thanks.